How are you guys? Welcome back to my YouTube channel. Today we'll be we're continuing right from we're still under strength of material N5. This is we're still under compound bars. We'll be dealing with parallel. We'll be looking at parallel bars, bars that are placed in parallel. So before we can go forward with this video, if you have not subscribed before, or if it is your first time watching my video, you may kindly subscribe to my YouTube channel and also click that notification button so that you'll be notified whenever I post a new video. So thank you. Let us indulge in this question. We given example 3.2. Read as follow. A rigid a rigid rigid beam hangs from three wires. You have three wires. Each is three. Each, you see, each you have 3,5 at 3.5 long each. That means they have same length. The two outer wires are made of bronze, right? And the central wire is made of a steel. Understand? I can do this. Simple, you understand. Can do this. Same length. Wanted to show something. Same length. They are hanging there on the beam. This is what they meant. As you can see, the outer wires are made of bronze. This one made of bronze. This one made of bronze. The middle one, this is made up, or the central made up of what? Of steel. I'll just let me not write like, yeah, steel. I'll just say S. I won't write it in full. Let me just say S. Right, as you can see, this is what is going on here. Then the beam placed under a load of 3 kilonewton. That means the load will be experienced by these bars will be that one. So as you can see, that means it's the total load. The diagram of each bronze, the diameter. So why I'm saying diagram, the diameter of each bronze wire is this. We've given the diameter of the bronze is fine, and the diameter of the steel. They have different diameters. As you can see, these have identical diameter, which is 4 millimeters. As you can see, also that one, but this one has 3 millimeter. It's not identical. Young modulus of the steel is this. Young modulus of the bronze is that. So they say here we should calculate the stress brought about each wire. Stress. We know that to calculate the stress will be some long process. These are compound. You cannot just calculate it straightforward with different. So must be very, very, very careful. Okay, question A there. A there, given A. Want to calculate the stress brought about each wire. So good. This is very nice because now we have the areas. You may say the area. Let's just calculate the cross-sectional area. Let us be specific. I'll say S. S is for steel. I won't write it in full. Then you know that it has a diameter. Cross-sectional area of the diameter of the circle is like this, or pi over 40 squared. Then will be pi over 4. We have seen that was 3 millimeter. Divide by 1000. Then you'll get this to be 0,003. Then you square this guy. Then you punch this on your calculator. You'll find out the area to be 7,0686 times 10 to the minus of that 6, but it's measured in squared. Then the area now of the prawns, but I've sketched for you the prawns. We have two prawns, two prawns, two, and then they're identical. They have identical diameter, identical. So it's obvious that you'll have 2 then multiply by the area of this what of the prawns, because they are the same. So will be 2 multiplied by that area we know is pi over 4 multiplied by d squared. So we know it was 4 millimeter. We divide this by 1000 to be in meter. Then this will be 2, because they are identical, they are 2 multiplied by 2, pi over 4. The diameter will be 0,004. You square this guy, then like that. Don't forget to like this so that you multiply accurately. So what is the area of the two bras? But you can see here is the area of the two bras, but I'll just say bras, area of the bras, because now we'll count them. Now it will make them two, will make them to become two things. Remember, we've just collected them. We've calculated the area of the two. Oh, sorry, my pen is falling down. Wait a moment, guys. Sorry about that. Oh, let me pick my pen. Sorry about that. My pen just dropped down. So yeah, we've made them to become a compound. Imagine we have steel. Let's say we have a steel 1 and steel 2. They have the same area. Then you decide to compound to sum up their area. That means you've made them one thing. At the result, you'll have something like this. So we've made, since we have calculated the area of these two, the result will have two things now, but now will be enlarged. The size, the length will be the same, but now will be big. Now here we'll have our little small of our steel in on the side there. The length is the same, but now we'll have the bronze, we'll have the steel. Now they will be what? Two things now, because we have tried to have combined these areas, right? We've calculated like that. So nevertheless, then the area if multiply there will be 25 comma 133 times 10 to the minus 6 meter squared. We have this. Now it's for all of that. We know now we know our formulas for parallel, right? Parallel bars, we cannot make mistake. We know that total force, for argument's sake, we know that total force, you can say T, Ft, which is total, or I can write that total. We know it will be force of the steel. I will write it as S. Just say S plus of the bronze, right? F of the, what is wrong with this pen? Since it's falling down, it's making some nonsense now. Okay, sorry about this. Okay, this will be F bronze. BR like this, I will say it's a bronze. So we know that the force, we are not given, but we know that the force is equal to what? To strength multiplied by air. From this formula, strength is force multiplied by air. Then if you make area the subject, you'll have that. So, but we'll be specific. We'll substitute that, but now we are specific. Will be the stress of what? Of the steel. Here, of the steel multiplied by the area of the steel plus the stress of the bronze multiplied by the area of the what of the bronze. So now we are specific. Here we still have that total of the two. What we have, are we given total? Yes, the load is 3 kilonewton that we experience. So we have 3 kilonewton, which is same as times 10 to the power of what? 3, like that. Then we have equal sign. We don't know the stress, but we know the area. The area of that guy is the one that we've calculated, still is there at the top, 7,0686 times 10 power minus 6. We have that, which is, it was 7,0686 times 10 to the minus 6, multiply also by what? By that stress of the what of the steel, because we don't know that stress, plus the area of this we don't know, we'll leave it, but the area of this is the one that we have there, 25,133 times 10 to the minus 6, 25,133 times 10 there to the minus 6. Then we don't know the stress of what of the brass, like this. So what can we do? We have two unknown. In maths, if you have two unknown, then you cannot do anything. We have two unknown here. So I can call this, for argument's sake, equation 1. That will be equation 1. What do we know? We use what we know. We know also, suppose it must, because they are parallel. What do we know? The laws in parallel. The extension of the steel, the changing length of the steel must be the changing length of the bronze, also PR, like this. So, but we know this is force multiplied by length over area over E. Also again is stress multiplied by length over E. So it's up to you which one you want to choose, but I will choose this one of the strength, because I've decided here to use this, to have the strength is there. So I'll use this one that says, but here I'll have strength of what? Of the steel. Strength of the steel multiplied by the length of the steel divided by Young's modulus of the steel equal to the stress of the bronze multiplied by length of the bronze divided by E of the bronze. But now you must know the length is always here, isn't it? They are parallel, and then they said they have the equal length. They said they reach it hanging 3 wires each they have, it was same length, 3,5. Since is, you know, mathematically, if you have equal sign, what is the same, you'll cancel that side. So we'll left with this, apparently we're left with this individually. So suddenly we'll have this out of the blue, like that. We'll just cancel that because they are the same, because those lengths are the same. The length of steel is equal to the length of the bronze, so we know that. So of the bronze, so let us try and make our things and see what we'll do. Okay, the strength of this, I don't know. Young's modulus we've been given, which was what? Let me just take them. We have 27 gigapascal. This is 90. That one, the other is 9. Okay, 207 times 10 to the power of 9. The other was 90. Of the bronze, it was 90 times 10 to the power of 9. This is what we have. This is what we have. So I can I'll multiply there, I'll multiply here, I'll make this the subject. If I multiply, I will have that to be 270 times 10 to the power of 9 multiplied by the stress of the bronze divided by 90 times 10 to the power of 9. This and this will cancel because it's the same. Or do not waste your time, just punch this thing once. If you punch that, you'll get this to be in your ratio. There will be 2 comma, we'll have this as an equation, trim stress of the bronze. This will be equation 2. Then we can substitute equation 2 into equation 1. Where is our equation 1? Here it's equation 1. Here that is our equation 1. So I can copy this, then I will paste it here so that you'll see. Paste these equations. I've just taken that there. So this is our equation 1. So we can substitute where we see the steel, the stress of the steel, will substitute this value there. So at this side I still have 3 times 10. No, still have this, but let us substitute. That will be 2 comma 3 bronze plus 25,133 times 10 to the power of minus 6 bronze. So we have bronze. So yeah, substituting there. Multiply this. You start by multiplying this. After you've multiplied this, you add this guy. If you know that is your maths, you know what to do there. Then if you know what to do, isn't it? Then you'll have these guys to be 72. After you've done that, you know what to do. Just multiply and add. So or you can do like this. Yes, you can do like this if you want it to be nicely. You can say 7,0686 times 10 to the minus that. We multiply this by 2,3. Right, take out the common factor. There we have plus 25,133 times 10 to the power of minus 6. You took out the common factor there, like this. Multiply by BR. Then you divide by whole of this. Yeah, divide both sides by whole of this, isn't it? Then you know what to do. Yes, you divide. You'll also divide by this, both sides. Also you divide it there. You know what to do. Therefore, if you divide accurately there, you're supposed to get BR will be equals to 72,48 megapascal. This is what we'll have there, which is fine. We have this now of the bronze. But what about your is the strength? I'm just writing bronze. Yeah, sorry guys, I forgot the symbol, but as you can see, there must be the symbol there. I don't know why, but yeah, there must be that symbol for stress. You see, the symbol there. There must be the symbol for stress that illustrates. Yeah, as you can see, guys. Therefore, we have to find the stress of the steel again. Can use this equation too. Remember, we had that equation too. You can substitute there. This is 2,3 7 2,48. Then because I substitute this in megapascal, also this will be in megapascal. So will be 166,705 times megapascal. This is what we have. Then you know how the cookie crumbles. We should calculate. We've calculated the stress that brought about. We have done about A, the B. We've done up to calculate the stresses brought about each wire. Then now calculate the extension, the change in length. Then change in length, your stuff. You see, we have the stresses, isn't it? We cannot just, since we said we should calculate the stresses, it's up to you. You know the formula, right? Will be stress multiplied by the length, isn't it, over Young modulus. So it will depend. You choose to use what, the steel, or you want to use the bronze. It's up to you actually. It's up to you. You can use, let's say you can use the steel, but you have to use the strength of the steel, the length of the steel. We know that the E of the steel, or you can use that of the bronze multiplied by length of the bronze, or E of the bronze. They are the same, isn't it? Remember, they will be the same. It's one and the same thing. So it's up to you which one we use. You know this, it was 166,705. We've got it here. But was megapascal, isn't it? Times 10 power 6 multiply by the length. Remember, we've given that was 3.5 ish. Then the modulus, or Young modulus of elasticity, was this. Then multiply times 9, like that. If you have this, therefore if you punch this, change will simply equals to what? Simply equals to what? The answer that you'll have, let me check, will be 0.002819 meter. If you want it in millimeter, you multiply by 1000. Then this will be 2,819 millimeter. But we know that x of the steel will be equal to the x of the what, of the bronze, also will be equal to the total that. So yeah, we know this. So it will be one of the same thing. Yeah. So what do they say here? Let's see. Discuss why the beam stays horizontal like this. Why would this not work with one bronze and one steel? Why? discuss why the beam stay horizontal. Okay, it's fine that way. Why this will not work with one bronze and one steel. Is all I could say is, remember, if we just compounded that, because remember these two, the two outer wires were made, I said they're made from same material, which one brass and the one steel wire will still stretch more than the other, so the beam will not stay horizontal. But however, this will stay the same because will be balanced anyways. You'll know how you, it's up to you how you will understand these guys. So anyways, do not by the way, please do not forget to subscribe. By the way, if you have not subscribed, don't forget to subscribe. By the way, also I've shown you the subscriptions. I've just written here subscribe there with the red in here. You see there, I've placed the picture there to show that you're supposed to subscribe. You can go to my YouTube channel there. Just click there and click the notification bell so that you'll be notified whenever I post a new video. After you've subscribed, also you can press the notify button. You'll be notified whenever I post a new video. So stay tuned, guys. Stay blessed. Thank you for watching, and then feel free to comment. Feel free to share this to your fellow classmate. Feel free to like. Thank you.